Math problems number 140.
Math problems number 140. So we had an awesomely fun morning, right?
Yeah.
We played around with what is 0.11111 repeating forever
In other bases.
in other bases.
Whoa.
And the one thing we just had to remember is in any base, like in base 10, the easy number to multiply by
is the base number.
is 10 because it just shifts all the numbers over, right? And in base 4, what's the easy number to multiply by? 4. Because again, if we have a number like 321 base 4, this is 3 times 4 squared.
Yeah.
That's 2 times 4 to the 1.
Yeah.
Plus 1 times 4 to the 0. And it just shifts the numbers over when I multiply by 4. 4 times this is 3 times 4 cubed.
3 times 4 cubed. 2 times 4 squared.
And
1 times 4 to the first power.
4 to the first power. And then no 4 to the zeros.
No.
No. Okay. So this number, we use that fact to understand this number. So first we looked in base 2.
Yeah.
Which is also called what?
Binary.
Binary. So we have 0.11111 dot 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 dot. And what this means is a half.
It's half.
That's the 1/2 digits. Plus a fourth.
Fourth, an eighth.
Plus an eighth. Plus a 16th.
16th all the way on forever.
And we've studied this before, so we already kind of know that, or suspect at least, that this equals what? A half plus a fourth.
1 forever.
This
If you
equals
go on forever.
Okay. But we're going to approach that problem in a slightly different way today. We're going to call this number x. And what's our easy number to multiply by?
2.
2. So what does 2x equal?
2x, you shift over, it's 1.11111. And then
x was 0.111.
So if you subtract, you get 1.00000 forever, which is 1.
And what do I get when I subtract on this side? 2x minus x?
X.
X equals
1.
because this part all goes away.
Yeah.
So in base 2, 0.1111111 equals
1.
1. And then we decided to look, let's do 2 more different bases. So pick a base.
Maybe 5. Base 5.
Ooh, base 5. What is 1111111 in base 5? I don't even know. We didn't do that one before, did we?
No.
No, so, but if we do the same kind of idea, what should we multiply by here?
5.
So what does 5x equal
5x
in base 5?
5x is 1.11111.
1.11111.
And then x is 0.1111111. And you subtract, and that gets to 1, but you have 4x.
4x equals 1.
That means it's 1/4.
X equals 1/4. Wait a minute, this number in base 5 is 1/4? What? That's crazy, right? Because this is the 1/5 digit.
Yeah.
1/1/5 plus 1/25.
Yeah.
And what's the next digit?
1/125th. I think it's
125th. And we just keep adding
all of them.
inverse
together.
powers of 5.
Wow.
Make it a 4th.
What?
What?
Looks like the denominator is 1 lower than the base number.
That seems like it is the case. All right, let's do one more. One last example. Pick a base.
Maybe base 7.
Ooh, base 7. Okay.
So we'd like this to be 1/6.
We're hoping this is going to be 1/6. Okay, so what are we going to do?
Multiply by 7.
7x equals
Is
1.11111.
Subtract x from it is 1. So and then you get 6x is that. So and it did equal 1/6.
Whoa! So in base 7, 0.11111 is 1/6.
Yeah. Wow.
Yeah. Wow. And what is it going to be in base 10 if we use our method?
It's gonna be 1/9.
1/9. And this is how we're used to seeing this in base 10. So if we normally if we write out a decimal like this, it's in base 10, 0.111, and we're saying this is 1/9 by our method. And let's see why that's true. Okay, let's multiply both sides by 9.
Yep. And then
What's 9 times 1/9?
9 times 1/9 is just 1.
1. Does 1 equal 0.11111 times 9?
We don't
What is that?
We don't. So you have to multiply every digit to 0.999999 repeating.
Does 1 equal 0.999999?
Yes, it does.
How do you know?
We watched it in a video.
Oh yeah? Whose video was that?
By heart.
By Heart told us that that was true. All right. Hey, that's awesome. Good job, sweetie. That's a fun morning, wasn't it?
Yeah.
Yeah. All right. Cool. Whoa! I just spilled my coffee. Whoops.